Hello, you are welcome back to the continuation of permutation and combination. And in this the third video rather, we are trying to look at permutation with repetition. In the previous video, we talked about permutation without repetition, but here we're talking about permutation with repetition. By the end of this short video, you should be able to arrange objects or things in a row with repetition, and then also solve problems involving permutations with repetitions. Now let's start with this. If I have just a letter A, in how many ways can this be arranged? Yes, it's one way because we saw that at our previous video. That is only one way you can arrange this one. What if I have two letters but they are the same, A and A? In how many ways can this be arranged? I'm sure you are right by saying one way. If I put A first here and I put this A, it's the same thing. When I interchange the position, I'll still get the same arrangement. So that is also one way. Now this time around we have AA and B, meaning we have three letters here, but two of them are repeating. In how many ways can we arrange these three letters with two of the A's repeating, or A is repeating? Now, in arranging it, we can put maybe the first A here, put the next A here, put B here. This is one way of arranging in a row. We could also do it by still keep one A here, B and A. This is also a second arrangement, different from the first one. We could also do B first, A and A. What other way can we do this? If we keep B first again and interchange the position of this and that, will be the same arrangement, so there wouldn't be anything different. And so here we say we have three ways of arranging AAB when the two A's are repeating. It's like if I asked you to arrange car like this. Because we have two of the A's repeating, we'll get the same arrangement as three ways. Now this time around we have four letters. Three of them are repeating. We are trying to build a formula for this as well. And again, if I put the position first, second, third, fourth, fifth, so first, second, third, fourth, I can have the first arrangement to go this way, and the second one go this way. So we have two different arrangements here. The first one we have A A A B, A A B A. Then we can also have A B A A. We can have B A A A. And I'm sure these are the possible ways we can arrange the four when three are repeating. So we see we have four ways. So let's see the pattern that we are flowing with. When we have AA, that is two letters and the two of them are repeating, it was one way. Three letters, two are repeating, we have three ways. Four letters, three are repeating, we have four ways. Five letters, four are repeating, will give us five ways. So if I have 10 letters and 9 are repeating, I will get the 10 ways. All right. But then let's see. If I have 6 and 5 are repeating, I'll get 6 ways. But I can rewrite this number of ways also in a different pattern. For this particular 3 ways, I can write it as 3 factorial divided by the 2 that are repeating. Take note that from the onset, we said that if I want to arrange can, no repetition, the answer should give me 3 factorial ways. And this time around, let's say n is repeating, like CNN. Okay, So I'll still get a 3 factorial divided by the number of n that are repeating, which is 2 factorial. And that will give me the same answer as 3 ways. So if it is 4, I will say 4 letters will be 4 factorial, but 3 are repeating. Then I'll divide by 3 factorial, and I'll get the same as the 4 ways. If I do the same thing for 5 and that of the 6, it will follow that pattern. So if you have, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9 letters, assuming there's none of this repeating, the answer could have been 9 factorial. All right, but because 8 are repeating, then we divide by the number of repeating letters, or the number of letters that are repeating, and that will give us the 9 ways. And here we have 11 letters in all, and 10 are repeating, so that will give us 11 ways. Now, what are we trying to build here? In general, write this information, they're very important. In general, the number of ways of arranging in a row or line of n objects, n number of objects of which x are alike, then we get n factorial divided by x factorial. This can be extended by saying that, or can include x number of items, or let me put it this way, this result can be extended to include x of one type, y of another type, z of a third type, and so on and so forth. Now, if that is the case, then it means that we can generalize our formula by saying n factorial divided by x factorial times y factorial times z factorial. So if I have, let's say, a word like what word would be appropriate for this example? Okay, well, let's take example. Maybe that will help you to understand better. Let me go through the examples here. We have a question like, in how many ways can the word statistics be arranged in a row? Now, here, let us assume that the word statistics, there is no repetition of letters. We could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our answer from the second video that we did could have been 10 factorial ways. But 10 factorial ways, yes, we are going to have some of the letters repeating here. S is repeating, and S is repeating how many times? 3 times. So we say divided by 3 factorial. Then there's another type that is repeating, T1, T2, T3, another 3 factorial ways will be multiplied down there. Then you can also see I repeating 1, 2, then times 2 factorial again. So that will give us 50,400. That means 10 factorial divided by 3 factorial times 3 factorial times 2 factorial will give us 50,400. I'm sure it makes sense. So you see the difference between when we have repetition and when we don't have repetition. When there is no repetition, we look at the whole letters, we write the number of letters. If it is 5, we say 5 permutation 5, or we can just say 5 factorial ways. But if there are some repeating, then we mention the factorial, then we divide by the number of letters that are repeating. Now let's take another example. In how many ways can the word optimization be arranged in a row? You can pause the video and try your hand on that. Good. I'm sure your answer came as 12 factorial divided by 2 factorial times 3 factorial times 2 factorial again. What it means is that T1, 2. So that's representing the 2 factorial part of it. Then we have I1, 2, 3, and that represents the 3 factorial down there. Then we have O and O again repeating, and so then that becomes the answer. In how many ways, or in how many different numbers of 5 digits can be made using the digits 22333? Here there are repetition of numbers, and so how many are repeating? 2 of the 2's are repeating and 3 of the 3's are repeating. So in doing it, you can say the answer is 5 factorial, having all the numbers 5 divided by 2 factorial, and then times 3 factorial. You can pause the video and try your hand on this one too as well. Let that be our last example under this. In how many ways can 4 white and 3 balls be arranged? I'm sure your answer came as 35 ways. So with this, we come to the end of this video. Thanks so much for watching.